All right, so let's look at this next equation. Well, I shouldn't say equation. Let's look at this next relationship. So it says that a bathtub is being filled with water. After 10 minutes, there are 75 quarts of water in the tub. Then someone accidentally pulls the drain plug while the water is still running. The tub begins to empty. It loses 15 quarts in 5 minutes. And then someone plugs the drain and the tub fills up for 6 more minutes, gaining another 45 quarts of water. After a 15-minute bath, the person gets out and pulls the drain. It takes 11 minutes for the tub to drain. So the domain, remember the domain is the x values. So this is the domain over here. Write this down on your paper. Whatever I write down, you write down. And then the range is from 0 to 105. So the highest this goes up to sounds like is 105. And the range are the y values, but in this particular case, instead of saying x and y, they say t and capital Q. So this is like x, and this is like y. All right? Are there any questions on that? And then the important thing that I want you to really pick up on is that the tub's behavior, right? So there's 0 quarts of water in the tub. I run the tub water for 10 minutes. It gets all the way up to 75. Then I accidentally pull the drain, so it starts to empty. I realize the drain came undone. I plug it back in. I fill it all the way up to 105 quarts, which is what I wanted. Then I sit I go, oh, wow, nice, the tub's full. I sit and take a bath. When I'm done with my bath, 15 minutes later, I get out. I drain the tub by pulling the plug. And the water slowly drains out at a constant rate until there's no water left in the tub. Does that make sense? Yeah. So now I want you guys to do this. Answer these questions. So it says sketch the graph of a situation and tell whether the graph is continuous or discrete. Okay? And we're just going to do this off to the side a little bit. It says at the start of a snowstorm, it snows 2 inches for an hour, 2 inches an hour for 2 hours. Okay? Let me just see something real quick. Shoot. Do they give us a place to sketch the graph? I guess we could write it down here, but I'm just going to do it over to the side. So the first thing I'm going to do is I'm going to create a shape. All right, so I'm going to draw my little graph. This is my y-axis. I don't like that. This is my y-axis. And then this is my x-axis. Okay. We got to label that too. So it looks like we're going to measure the time. So let's label this as time. And let's measure this as snow in inches. Okay. So now it says that it snows for 2 inches an hour for 2 hours. So somewhere over here, I'm going to put 2. So this is my time, 2 hours. And it goes up to 2 per hour for 2 hours. So this would be 4. So I'm going to draw a line from here to here. So we're assuming that we had 0 inches of snow. Okay. Then it says that it slowed to 1 inch an hour for an additional hour. So at 3 hours, it only went about half as much. And then after 3 hours, the snow had stopped, and it began to melt a half hour and an inch for 2 hours. So then way over here, 3 hours later, it stopped snowing. Well, the snow didn't go away. It didn't melt until this time, and then it slowly melted over the next 2 hours, where t equals 8. So right here, I think we've got 5 inches. So then my domain for this first one, the domain is time, and it looks like it went from 0 to 8, I think. I think we can include the 8. And I'm just double checking and thinking if I've missed anything. So let's reread this one more time. It says that the start of the snowstorm, it snowed 2 inches an hour for 2 hours, which would put us at 4 inches. Then it slowed to 1 inch an hour for an additional hour. That would add another inch, which is 5 inches. Then it stopped snowing for 3 hours. Okay, so that stayed at 5 inches, and then it slowly melted at a rate of 1/2 an inch for 2 hours. Oh, wait a second. And 1/2 an inch an hour, so in 2 hours it only melted an inch. So I'm not quite accurate on my graph here. So if it only melted and 1/2 an inch for 2 hours, it just came down 1 inch. So it went like this. And that's where the snow was. The snow was at 4 inches. Okay. So let me just double check my fancy teacher book. I wanted to double check to make sure that I did that correctly. So the first question is that accurate? Let's also define, so this is the domain, and then the range would be 0, we'll just call this S for snow, 5, yeah. So yeah, my graph is pretty accurate. So I'm going to draw some straight lines in here. So from here to here, and then from here to here, and from here to here, and then from here to here. So we got this point here, this point here, this point here, and this point here. Does that make sense? Okay. Now, is this a discrete or continuous? This is continuous. Discrete will have a bunch of dots. Okay. So I'm going to stop right there and post it. Well, actually, no. We'll do one more and then we'll call it a day. So this one says, the next one says a local salesperson is going door to door trying to sell vacuums. For every vacuum he sells, he makes $20. He can sell up to 10 vacuums a day. So same thing. We're going to draw our XY plane like this. And then I think we're going to do the number of vacuums here. And then how much money he makes. We'll say profit. And it says that he makes $20. So if he sells 0 vacuums, he makes $0. If he sells 1 vacuum, he makes $20. If he sells 2 vacuums, he makes $40. And then 3 vacuums, 4 vacuums, 5, 6, 7, 8, 9, 10 vacuums. If he sells 10 vacuums, he'll make $200. Now that's not exactly drawn to scale because I'm running out of space there, but this is discrete. It's not continuous. You're never going to sell a half a vacuum. The range, well, let's do the domain. The domain is the number of vacuums goes from 0, we can include 0 to 10. Profit, we'll just say P for profit, goes from 0 to 200. But you got to write that one a little different. I have to say that these are whole numbers. So the range, just remember somewhere down there say whole numbers only. In other words, I can't say 2.5. Boy, that looks bad. Let me erase the word discrete. We'll make some adjustments here. So this is discrete. And we're going to use whole numbers only. Okay? One last question. It says, when interpreting graphs of real situations, can the slope of each part tell you about the situation? Yes. It is the rate of change. How fast something changes or how slow something changes. The steeper the line, the quicker the change. If it's a positive change, there's an increase in value. If there's a negative slope, there's a decrease in value. Last one, it says, how can you tell when to use a discrete graph as opposed to using a continuous graph? Discrete is counting with whole numbers. I'm going to expand that and say counting on a set interval and then one example would be whole numbers only. Most of the time it's whole numbers. How many students does Mr. Adams have in his class? That would be discrete because I'd never have a 0.5 student. Does that make sense? But now let's say I have a bottle of pop. Those are 16.9 ounces. Well, I have 7 bottles of pop, so I've got 16.9 times 7. The values are going to jump every 16.9 because that's how much fluid is in one of those bottles, but it's the same set interval. So usually you're counting something, okay? So it's not always whole numbers, but most of the time it is, okay? Any questions on that?